All right, so in section 8.3, we're going to cover hypothesis tests of a population proportion. So our notation for a population proportion is P. Population proportion. So P should be the parameter that's going to be in all of your null and alternative hypotheses. As with other tests, you need to make sure that it meets some minimum requirements. The observations are to come from a simple random sample, and that the number of successes and number of, should be Q here, number of successes and number of failures is at least 5 for each. So number of successes and number of failures, have at least 5 of them. If that's the case, then we can make a normal approximation to a binomial distribution and then calculate some z-values based on that. No surprise here for us. We're going to use some technology to kind of circumvent steps 2 and 3, or excuse me, steps 3 and 4 on this. So instead of deciding on the critical values from a z-distribution, we're just going to get the p-value after you enter some data. So we're going to have a more modern version of steps 3 and 4. The rest of it is kind of like all our other hypothesis tests. Step 5 is you're going to decide to reject or accept. Actually, accept is not used much anymore. It's reject or fail to reject, and then state your claim in words. If you had to construct a confidence interval by hand, this is what you would do. With that, let's jump in and do a couple quick examples. We'll start with problem number 10. So this is section 8.3. Problem 10 can be found on page 408. Oh, 409. My bad. Going back to the M&Ms, 8% of them are brown. Do they even make brown M&Ms anymore? Do they? Okay, all right. 8% of them are brown. Test a claim that of the M&M Mars company that the percentage is equal to 13%. So we have data from 100 M&Ms and 8% of them are brown. So how many were actually brown out of this sample? 8. Yeah, so 8. So n equals 100, x equals 8. So there's a couple of numbers we should get out of this. But some other stuff we should get while we've got this open here are the claim that we're going to test. Test the claim of the Mars Candy Company that the percentage of brown M&Ms is equal to 13%. Oops. I guess I wrote these numbers in the wrong spot. All right, so that's the claim that we need to test. What parameter is that we're testing? Mu, sigma, or p? P. It's a population proportion. So is this going to be part of my null or alternative hypothesis? Tad? What do you think? Is this going to be part of the null or alternative hypothesis? That the percentage is equal to 13%. Yeah, the null, because it contains a possibility of equality. So we'll start out by writing h sub 0, p equals 0.13. If that's the null hypothesis, what's the alternative hypothesis? Yeah, it's something other than 1.3. or 0.13. What that means is that our confidence interval, if we concluded that HA was true, our confidence interval should not contain 0.13. It should be someplace other than 0.13. If we conclude or fail to reject, then our confidence interval should contain 0.13. All right, so that's step one. Step two. In this case, we want to do our test at the 5% significance level, so alpha is 0.05. Step three is where we enter some data. So for that, let's go to StatDisk. Any suggestions? Where are we going to go from here?
Hypothesis as proportion.
Yeah. So analysis, down to hypothesis test, and then proportions one sample. So again, analysis, hypothesis testing, proportions one sample. There was a couple numbers that I wrote down for us. That is that we had n equals 100 M&Ms, and 8 of them were our quote-unquote successes. 8 of them were brown. So let's enter that in. So let's see. What's the form of our alternative hypothesis? 1, 2, or 3? Let's take a look back here. The alternative hypothesis is that P does not equal 0.13. So in looking at StatDisk, choosing our claim, you want population proportion does not equal the claimed proportion. So we'll keep that one there, 0.05 significance level. Claimed proportion is 0.13. Sample size is 100 and 8 successes. So when you've got all these entered, hit the magic button and you get everything you could want regarding this hypothesis test. What's the thing that I'm going to look for first? P-value. In this case, the p-value is 0.1371. So that's step 4. P-value is 0.1371. Take a moment and carefully figure out what that means for us. You reject or fail to reject. Darlene? Yeah, fail to reject. Good. Fail to reject. Okay, back to wording our conclusion. What was our original claim? HO or HA? HO. So the original claim had the possibility of equality. Okay. Contained the possibility of equality? Yes. Did we reject? Did we reject H naught? No. So you're down to here. There's not sufficient evidence to warrant rejection of the claim that 13% of M&Ms are brown. Is not sufficient evidence to warrant rejection of the claim and now you got to go back and state that claim. That claim was that 13% of M&Ms are brown. Yes, sir. Let's take a look back here. So we're testing the claim that 13% of M&Ms are brown. Now, it might seem a little bit different, but that's because in this case the original claim has to be part of the null hypothesis. It includes the possibility of equality. A lot of our original claims ended up in the alternative hypothesis, which, okay, that's fine. But here, it's kind of like, well, prove me wrong. All right, I know you only got 8 of them. You're supposed to get 13, but that's in an ideal world. I mean, is it really that far off that you could say, no, 8 is too few, and I think your null hypothesis is wrong. The percentage is different. It didn't quite get to that level. You can see it with the p-value. I mean, 8, yeah, it's probably low, but it's not low enough to the point that we say, you know what, I think that H naught is actually false. So it didn't quite get there. And so that's a nice thing about the p-value, is that you can make your own subjective judgments. I mean, somebody might have done a particular test, and they did it at the 0.05 level, and they got a p-value of 0.049. Okay, that's pretty close. That's not as convincing as a p-value that we had earlier of 0.0055. That's really small. So, again, it's really nice to have the p-value there for us. Okay, anything else on this first one here? All right. Let's just move down a little step and work with number 12. In a 3M privacy filters poll, 806 adults were 806 adults, I should say, were asked to identify their favorite seat when they fly. 492 of them chose a window seat. Use a 1% significance level to test the claim that the majority of adults prefer window seats when they fly. So this one's got a little bit of a subtlety to it that we're going to have to work our way through. I'm hoping it's clear that we're testing a claim about a population proportion, because you're asked to test a claim that the majority of adults. So what does it mean to be the majority? What's that saying to you? Over 50%. So that proportion is greater than 0.5. So let's set that up. This is problem number 12. H naught, HA. That proportion is greater than 0.5. Kylie, is that going to go in the null or alternative hypothesis? Alternative, perfect. P is greater than 0.5. So Carlene, what's that going to put in the null hypothesis then? P is less than or equal to 0.5. Good. So remember, our null hypothesis always has to have the possibility of equality. Step 2, we're going to test this at the 1% significance level. So alpha is 0.01. Let's enter some data and then find our p-value. So the relevant information that we need here is that n is 806, and of those 806, 492 preferred, what was it, window seat? Yeah, window seat. Okay, majority. Now, one thing I should probably be better about, and I don't really get good at this until we start working with the chi-square distribution and variances, is you really need to check your assumptions. So if 492 of them wanted a window seat, then that means the rest of them didn't want a window seat. So that means the number of failures is 314. Yeah, 314. But both of these are greater than 5. We don't really need to do any hardcore math to see that one. But it is part of the assumptions of doing this test. If these assumptions aren't met, you should not be doing this test, period. Your conclusions would be invalid. So, sorry that I'm not a little bit better about doing those right up front. Okay, so let's go to stat disk. So, this time, which of these three alternative hypotheses should I choose? 1, 2, or 3? 2. Our population proportion is greater than the claim proportion. We're going to test this at the 0.01 significance level. The claimed proportion is 0.5. Sample size is 806. And we had 492 successes. So let's crunch the numbers. We get a p-value of, wow, p-value of a bunch of zeros. What that means is that the p-value is so small that even if you rounded it to the nearest 10,000th, it would still round to 0. Nonetheless, we still need to make a decision about the hypothesis. So, Jacob, what do you think? Fail to reject or reject? Yeah, reject. I mean, this is way less than any conceivable alpha we could use. All right? So it's extremely small. Very unlikely you would get this result just by chance if the null hypothesis were true. So we'll use a rare event rule and say, you know what? Probably the case that our assumption was wrong. So we're going to reject H naught. Let's look back at this one. Which one was our original claim? HO or HA? HA. We tested the claim that the majority of adults preferred a window seat. Okay. So that's your null hypothesis, or that's your original claim. See if you can't come up with the wording of the conclusion. Test yourself, quiz a neighbor, see what you can come up with. Okay. Volunteers on this one? What's our conclusion going to look like? Let's first of all figure out which one of these we're working with. Did our original claim contain the condition of equality? No. So we're down here. Did we reject?
Yes, we did.
Yep. So we're down at the third one. So should be that the sample data support the claim that the majority of adults prefer a window seat when flying. Let's look back at StatDis for a second. The nice thing about StatDis is that it gives us a little bit more than maybe what we asked for. It gives us a 98% confidence interval for this same thing. So it says we can be 98% confident that the proportion of the true proportion of passengers who prefer a window seat is between, say, 57.0 and 65.0%. So looking back here, we can be 98% confident that this true parameter, we don't know what it is, that true parameter though, is somewhere between 57 and 65%. Does this agree with our conclusion about the null, or rejecting the null hypothesis? Yeah. The null hypothesis would include the possibility that 50% of adults or less preferred a window seat. This does not include that possibility. This is basically saying, you know, whatever the true proportion is, it has to be more than 50%. So, nice. Your confidence interval matches your conclusion on your hypothesis. How are we doing on this one? Pretty good? Chris?
So, for like the third conclusion, would it be wrong to say instead of the sample data, there is sufficient sample evidence for protection of this claim? Like, I don't see the difference between 1 and 3 and 2.
All right, let me take a look at these carefully. There's sufficient evidence.
Besides one sample population.
All right. Support the claim. Well, the one big difference is the word reject, because in this case, the original claim had the condition of equalities, and we rejected that to get to our conclusion. In this case, it doesn't. So here we're just saying it supports it. Here we're saying we rejected the original claim to get to our conclusion, which is, and then you would state the alternative. Oh, see, no, you wouldn't be stating the alternative. Let's see. Reject H naught. So your conclusion, yeah, you'd be rejecting the original claim, so you'd state that we're rejecting that original claim here. And here you're supporting basically what's in the alternative hypothesis. So it's a little bit tricky. I like this as an instructor because it gives you a nice guide to follow. You're free to go off script a little bit. That's fine. But you know, I'm gonna have to read these things carefully. It takes me a long time to grade this stuff because I got to make sure that your conclusion matches everything. So if you think about it, first thing I do is I look backwards. I'm like, okay, what did they conclude here in step 5? Did they reject or did they accept? And does that match what they have up here in the null and alternative hypothesis? Because if you have some things backwards up here, I'll kind of follow through and try and give you partial credit later on, as long as you're consistent. But it just takes a long time to go through all that. All right, appreciate the question. Anything else on this one? Okay, for homework, try 5 through 19.